The Bureau of Labor Statistics reported that of high school graduates in 2016, roughly 70% attended college, 24% are in the workforce or military, and 6% are unemployed. What category a high school graduate falls into can be represented by graphs designed to display categorical data. The two most common are pie charts and bar graphs. Let's instead focus on a quantitative variable. Here is a histogram displaying college tuition and fees for 2016-17, taken from the College Board's annual survey of colleges. Keep in mind this is just tuition and fees, no room and board included. This is officially a histogram as it deals with the quantitative variable. Excel is nice in that it shows the intervals on the x-axis. Often a histogram will only show the boundaries of each interval, such as $3,000 or $6,000. We will understand that the interval begins with the number shown and finishes just below the next boundary, implying in the case of the $3,000 that the first interval was from $3,000 through $5,999. Compare these two graphs. Note the x-axis for each. The variable of interest in the tuition and fees is quantitative, and so are the values of the x-axis. For graduated seniors, it's categorical. We have the categories of college, workforce, and unemployed. The statistics from the histogram on tuition can include mean average, median average, and measures of spread like range. Categorical variables do not have a mean average or median, but we can and will study proportions such as 70% attending college. Box plots will be studied soon. We can make a box plot of quantitative data showing the distribution of tuitions, but we cannot do so for where high school grads go after graduating. Now we could make categories of intervals of tuitions and then produce a pie chart, which sort of breaks the rules of how to display quantitative variables, but this brings up a broader point. It's best not to say we can never do a certain graph with certain types of data. The better understanding when displaying and interpreting graphs is far more practical. Just look carefully at the x-axis or categories and the y-axis or frequency and proportions. It is always best to ponder and read and observe what information is being shared and what the variable of interest is. Do not get lost in strict rules that are often broken by sources anyway. As you go through the rest of the videos in this unit, you're going to see types of problems for which you will want to achieve solid understanding.